In the previous few videos, we had a look at multiplying two binomials. In this video, we are going to combine that with bigger calculations. Example 1. Simplify. Here you will recognize that we have two binomials or two terms being multiplied. Further on in the expression, we once again have two binomials that should be multiplied. The important thing to realize here is that there is a plus in between these products, which means there are two different terms. That is why we will have to start off simplifying each term on its own. In our first term, we have two binomials that are multiplied. With a closer look at these binomials, you will see that they are very similar. The only difference is the sign in the middle of the two brackets. This means that we can use one of our shortcuts. We can only multiply the firsts in each bracket and the last terms in each bracket. And this will then give us 25x squared minus 9. Now we can move on to the second term. In our second term, the two binomials are completely different. That means I need to multiply the 2x with everything in the second bracket as well as the minus 4 with everything in the second bracket. This will give us 2x squared minus 6x minus 4x plus 12. Now we've gotten rid of all the brackets, so we can add up like terms. Here we have two terms that have an x squared, and when added up, you will get a value of 27x squared. Another pair of like terms are the x terms, and when added up, you will get minus 10x. And finally, we can add up the two constant values, and minus 9 plus 12 will give me plus 3. In example 2, we once again have the product of two binomials in a bigger expression. Here we have a minus indicating the start of the second term. The first term consists only of a 2, and that will stay just like that in my first step because our order of calculation says that we always start with brackets. If I now focus on my second term, the two binomials, you will see that once again they are almost exactly the same, with the only difference being the sign in the middle. And again, this means I only need to multiply the firsts and the lasts. When you do multiply these, it is important to write your answer in a bracket, because the minus in front of the term has to be multiplied with every part of the term. If you compare this to example 1, you will see that in example 1 there was a plus in front of the term, and a plus does not change any signs. So in example 1, it wasn't necessary to write that answer in brackets. So in this case, we'll have 9x squared minus 1 in a bracket. In my next step, the first term of 2 still stays the same, and the minus of the second term will be multiplied into the bracket to give minus 9x squared plus 1. The only thing left to do is to add up the two constant values, and that will give us 3 minus 9x squared. In example 3, we once again have two terms, and firstly we need to simplify them individually. Our first term is a bracket squared, which means we have two identical brackets. For this, you now have a choice of multiplying everything in the first with everything in the second bracket, or using the shortcut. The shortcut will be the firsts multiplied with each other to get 4x squared, as well as the lasts multiplied to get plus 9. And lastly, it is the product of the two terms, which will be 6x. And this then has to be doubled to get our middle term of plus 12x. I'm reminding you that you can also write out the bracket twice, multiply everything in the two brackets, and then simplify to get the same three terms. Now I can simplify the second term, and here we have a plus 2x that has to be multiplied into the bracket. This will give us minus 4x squared plus 10x. In my final step, we can add up the like terms, and the first one will be 4x squared minus 4x squared, which is 0. Then we have a plus 12x plus another 10x to get 22x, and then the constant has to be added. From the three examples, you can see that multiplication of binomials can occur in many different expressions. The important thing to remember is to always start by identifying the number of terms. Then you simplify each term on its own, and finally add up the like terms.